And good afternoon, good evening, good morning, everybody. Welcome on into the Dragon's Den. My name's Digital Dragon. I'm a 3D printing variety streamer here on Twitch. What does that mean, you might say? Well, it means we do everything from unboxing and modifying some, such as the commercial off the shelf Bamboo Lab X1C here with an S, to doing full printer builds like the Annex Engineering K3, the 0G Mercury 1, and the Vorons that are kind of over here hidden in the corner, as well as this huge, beautiful beast right here on the workbench, which is the Black Box CE. So with that, I did want to start off with this still on the bench. Pops into lurk. Okay, Phantom, because I just wanted to show everybody we did get first movements last stream. So we do have it wired up. We do have the basic configuration installed. And as you can see, she moves of her own accord, homes. And that's about as far as I got. There's still plenty more tuning to go on this that we'll get into on Saturday. But I just wanted to show that we do have movement. She is alive and well, and doing her thing. So with that said, I am going to drop the bed down a little bit lower because weight lower is probably a good thing. But I am going to shut her down so that we can clear the workbench and get ready for the next build. Well, the next project that we're going to start here on the, yes, Black Box. Black Box is moving, Zombie. So we have made progress. She is moving of her own free will. Not of her own free will, but she is moving, which is good. We are going to be pulling her off the bench, though, because we are going to be working on an MMU3. Now that we've got her to this stage, though, on one of the next streams, we will be adding water so that we can start testing all the heaters and stuff like that out. So, and God, she is getting to be a heavy girl. Heavy girl. We're over here out of the way. We still have the EasyBot that we're working on. We've got all the main power wiring done. We will be working on her tomorrow on getting the rest of the wiring done. So hopefully we can have two brand new printers that are doing first moves here within the next week. Let me move a couple of things around here, because my goal is to be able to sit down a little bit during this stream. I know that's going to be kind of weird, but yeah, we're going to sit down a little bit, hopefully. Hey, Zombie, I did want to say that I kind of sort of pulled one of your things. I got up this morning and yesterday morning. I got up yesterday morning, came over, and of course, the first thing I did was, hey, let me grab the print off of the Bamboo, and I can get the next print going because there was a print that was running overnight. I didn't even think about it, didn't even tap the screen to look at it. I just opened the door, reached in, grabbed the plate, and lifted it up. And as soon as I did, I was like, why is the plate still hot? Oh, it may have just finished. So I clicked the screen and I realized it was at 85%. I said, crap. So I tried to put the sheet back in there, but as you can tell, my placement was off. The good thing is these are the only two pieces with the shift. So I just have to reslice these two pieces and redo them. So I'm printing everything else and I'll come back and do these. But these are pieces for the Milo mini mill. Yeah, so This is all my fault for not looking before I reached in and grabbed the parts, just assuming everything was done. Didn't even look up at the filaments, but it was my own fault. I ran out of filament, and had I noticed it, I would have just popped in the new spool of filament and gone. But I'll say, how about them overhangs? I mean, a little bit of the first, the outer layer there, but print in place with small overhangs like that. I mean, this is the Fadis ASA carbon fiber blue, or excuse me, glass fill blue. These are printed beautiful parts. So we'll be starting on Milo after Murph. I'm going to change the screen real fast so you don't see me as I drop this down. And it is what it is, Bob. At least it was it was 2 parts. It sucks. I'll have to double check. I should have enough filament to do the 2 parts. If not, I'll print them one at a time and order another roll if I already haven't. But yeah, it's not going to be that hard. So today, make sure I don't dox myself. We're going to be working on the Prusa MMU3. And the goal is just to get this assembled today. We're not going to be doing anything crazy like trying to get it on the printer and go, because the printer's actually printing things. But this is the version with the printed parts. So I did go ahead and order the version with the printed parts. Not that I couldn't have printed the parts myself. I was just being lazy. And it was not that much more. And for the time saved, it was like, yeah, we'll let Prusa print the parts. I mean, I bought a fully assembled Mark IV. I did not do the Mark IV build. So yeah, pulled a zombie hedgehog and yanked the print before it was ready. Exactly. Exactly. And it happens. I just figured I'd tease zombie because why not? So just like everything else, we get nice, good packaging with labeling on the package as to what's in the package. We've got the thank you for purchasing the MMU3, places to follow, assembly guide instructions. I've already brought those up. And the nice cheat sheet of all of your fasteners. And the nice thing is these are 1-to-1 size. So if you're looking for a specific bolt and you spilled your screws or nuts or whatever, you can just put it right on this sheet and know what size it is without having to go figure it out and measure. The 3D printing handbook, which is always nice, and it comes with stickers, which is always cool as well. So we'll take this and put it aside for the time being. Got the package of Haribos. We'll have to keep that nearby. Hey, Pez Liz, how's it going? Sorry, you call it a Zolon? Okay. So this looks like the motors and multiplexer. Yep, all the motors for the multiplexer. That'll be nice. Printed parts. MMU3 for Mark IV plastic parts. Idler lever, nuts, screw guides. Okay, so that'll be some parts that we'll use. We have the spool holders and electronics. We're getting into that. The fastener and plastic parts for the MMU itself. So we've got the nice MMU parts already done. And the plastic pieces for the buffer system. Now, if you've got a previous MMU, this buffer system is very similar, just in the same um, shape, but there are some changes to this. So it'll be interesting to see what those changes are over time. But I do know that there are some changes. And let me switch the screen and bring up the instruction. Don't think I'll need this, so we'll over there for the time being. So how's everybody doing today? I noticed a couple of you were over at Free Heathens stream, or may still be over in Free Heathen stream. Good to see him on streaming again. Hey Karen, welcome on in. For those of you that don't know, Karen Chow Designs is now streaming on Twitch, so that is a good thing. That is a good thing. And I'm going to take a little bit of a seat here so that we can work our way through this. So if you've ever seen yeah, it's so weird to hear that. Exactly. Like if I ever start doing direct YouTube content, instead of just populating my videos over to YouTube, that's going to be a strange feeling as well for me on YouTube. But for those of you, if you've never put together a Prusa, their guides are very well laid out, very, very nice, step by step. You'll have the introduction section that just kind of gives you a little bit about what the different compatibilities are and make sure that you're in the right place. So if you're actually building an MMU3 for a Mark 3S Plus, it might be a little slightly different kit, so on and so forth. Gives you kind of the history. Supported printers that you can build this kit for. Make sure your printer is fully assembled and works perfectly. It's working perfectly because it's printing off some cookie CAD cookie cutters so that we can make some cookies. So Mrs. Dragon designed some cookie cutters and asked me to print them. So we're printing some cookie cutters in PETG on the satin build plate. And we'll be making some cookies. Tools that you may or may not need. I'm pretty sure I have all the necessary tools on the workbench at this point. When you browse the guide, you do the original images in high resolution. So it tells you about how to see things. The labeling we've already talked about. Every package is nicely labeled with what's inside of it, which is very nice. So very good. And they're here for you. There's comments. You can leave comments directly in the guides, and people can come in and add comments and get just-in-time comments, basically some tips, some tricks, printed parts. We purchased the kit with the printed parts, so it should all be good. And now it's time to clear off the desk, or in this case, get our stuff on the desk. You're ready to start building. So if you're building a brand new MMU3, which is what we're going to do, we're going to go directly to the idler body assembly. If you're converting an older MMU2S to an MMU, you got to do something. We're just going to start by going straight to the idler body assembly. It has 18 steps. You can download the entire manual if you want. Talks about which pliers and tools you're going to need. So the one thing that's not sitting within arm's reach is my pliers. So we'll bring that over here. So Idler version. There are two versions of the Idler. There's the older style MMU. Well, there's the MMU used with the metal coupler. Then there's an older style this way. Notice that there's this little nudge out here. So we're going to be using the newer style. Um, should all be in here. So the idler, the selector for MMU. So we're going to start with this one. Those are buffer parts. We'll put those over there because I want to grab the screws out of here. I have to dig through the screws. Safety stickers. Those can go. Get to those. Buffer MMU. Full holder PTFE holder. Fully body electrical MMU. Fasteners. Idler selector MMU. These two we're probably going to be needing for this part of the build. Okay. So we need our idler body part. And for those of you that aren't aware, when you get these printed parts from Prusa, these are all printed on their print farm using, they used to have the Mark II variants. Now they've got some Mark IIIS Pluses still there, a ton of Mark IVs, and a ton of the XLs. These parts are printed on their printers to basically, one, really do some long-term operational testing on their printers. So a lot of times they're finding issues on the printer before we do, just because they're using them in-house. Like XLs were being used in-house in their print farm, actually went live and out, which is a little worrisome. Just the simple fact that some of the issues that we still have with the XL, but from a Mark IV standpoint, these should all be really good parts. These are printed in their Prusa PET G to the exact standards that they would tell you to print the parts. Does that mean that they are flawless, that they are perfect, that there's no artifacts whatsoever? No. I mean, we're printing a molten plastic layer at a time, and I am seeing some. I don't know if I would be able to see some VFAs and ringing on these parts, trying to get the light to. But it's a perfectly serviceable part. Where I'm getting at. The print flaws that you see in here are not going to weaken the part, cause a strain or a break. These are just normal, and some of these I would say you would not be able to tune out in a print farm setting. And I say that because I see the same thing on mine. I've got multiple printers going on at the same time, and each printer has its own harmonic vibrations. So even if you've got all of the same printers like they do, like racks and racks of Mark IV printers printing, even if they were printing the same part at the same time, I mean, down to the microsecond, millisecond, you're still going to get ringing because they're moving the entire rack, right? You're never going to get rid of all that. So, oh, Killer Dragon, there are opportunities to get some of the Dragon printers or some of the printers that I have built on stream uh, at the shows that I go to. I parted ways with 2 printers at Rocky Mountain. I'm going to part ways with more because I am working on deals to bring even more printers into the Dragon's Den. I was just had a conversation with somebody today that said, okay, reach out after the holiday weekend, which would be um, Wednesday or Thursday, because they've got to get the orders from the holiday weekend out from the sale, and we're going to start talking numbers on what it's going to take to get me another printer inbound for another build. So yeah, and it's to the point where I've reached critical mass, and in order for new things to come in, some older things. But that's what I wanted to talk about was these parts. These parts are perfectly serviceable. They're still very pretty parts. Um, Black. So if they printed this in Galaxy Black, and I think they have a Galaxy Black PET G, um, you probably wouldn't notice a lot of the minor wiggles and squiggles, right? Because the flux or flakes that are in there would cover up. But perfectly serviceable parts, and getting them from Prusa, I know they're going to be built specifically and printed specifically with the right filament in the right way. If you get things from another place, I don't know. I haven't seen kits of these on AliExpress, but I wouldn't be surprised if they are. Um, just realize that the prints are probably going to be a little bit. We're going to need the idler body here. We're going to need the what are we going to need? We need the idler. We need the 625 bearings. It's going to be in here. We're going to need 5x16 S8 shafts. So we're going to need some bearings and some shafts. I'm going to dump things out here carefully because there are some steel balls in here. Those are going to go back in there. All our stuff. Our bushings. Those will go back in. What we're going to need is 625 bearings, 5 of them. And we're going to need 5 of the 5x16 shafts. I think that's all we've got. Yes. They're all looking to be the same. Yes, all those shafts should be. So we're good there. We also have some cutters, some magnets, and things like that. So nicely, they send all your cutters and stuff in plastic cases. They look like the SD cases. That's definitely good to help protect you. Okay, so, whoops, 6 of them. Or 6, 5. Need 6 bearings, but only 5 shafts. Okay, good. Read the instructions carefully. You have to assemble bearings in the correct order. Otherwise, you'll encounter problems later, like not being able to install any. Visit your local library or makerspace. Oh, yeah. True. Got you. So what I said, Killer Dragon, was I go to the shows. I will be going to uh, Midwest Rep Fest in Goshen here at the end of June, and then out to the 3D Printopia at the end of, when is that? End of September. And at those shows, there will be opportunities for uh, people to get their hands on a Dragon Den printer. Okay, so insert one of the bearings into the middle slot in the idler, insert the shaft from the, make sure you're inserting it from the correct side. So we're trying to get into the middle shaft, and you'll notice on this side, there's two big holes and then a small hole. It means we're able to get a tool in this hole, but we won't be able to get a shaft in that. So that means we're not going to be able to put it in here. So flip this around, you'll see that we have three large holes that will accommodate that M5 shaft. So this is the side we're going to insert from. We're going to take one of our bearings, just drop it right down in there. And then we're going to take one of the shafts, push it in through the side. And one of the things I'll say, try and do is just make sure that your shafts actually go in your bearings before you try and start shoving it in there. Otherwise, you'll have a issue. So we'll get it started, drop it down in there. I'm going to grab my 4, and we're just going to push that in. See the shaft coming through there. So push that all the way in, and it should go all the way, there we go, all the way in through the printed part here. Now that bearing rotates just perfectly. So that's the first one done. Sure the shaft is all the way in and not blocking the other bearing slot. Sure that that shaft is not visible in the next slot over. Because the next thing we're going to do is clock this in the next bearing. Install the second bearing in the shaft the same way. So just drop the bearing in, grab a shaft, sure that they're going through nicely, which they are. Up, home. Now we're going to do the third one, same exact way. Again, making sure and pushing it all the way in so it's in there and not sticking out the side. So we've got 3 of the bearings in. Now we're going to turn it around, and we need to do the last 2 bearings here. So rinse and repeat. Okay, so we've got all 5 of our bearings in there. Everything's working nice. Now we're going to install the other bearing, the last bearing at the end where we've got the hole at. Just realizing. Let me bring you guys close. Just realize that camera is really way far out. We'll bring it in a little bit closer here. So yeah, got this hole here now. Put in our last bearing in. Press fit in there. Flush. Sure that we're lined flush with the surface, which we are. Now we need to do some coupler part preparation. Means we need to grab this coupler from in here. Got the coupler, need some M3 by 10 screws and 4 by 5 grub screws. Six. 3 by 10. For these. Springs. Grub screws. No. And these grub screws already have Loctite pre-applied. So, there are things laid out. Using the 2mm Allen wrench, install the M4 grub screw into the threaded opening sides of the coupler. Okay. So there's 3 in here. We only need 2, so we'll grab 2 out and leave the other one in there for now. Thanks for the alert, Karen. Uh-oh. Is Dan the man? Hey, MakerMind Nexus, how's it going? Big decision when getting into a hobby. Oh, yeah. These tools I have built up over time. When you first start out in the hobby, it's perfectly fine to use the included Allen keys. Um, just know that over time, you'll want to get some nicer tools, which that's the best way to do it is over time. As you need tools and as you can afford them, you get nicer tools. But just about every 3D printer that you buy will come with some set of tools. In fact, this kit, you can add the option for the printed parts, and you can add the option for the toolkit necessary to build it. Same thing with their printers. You can actually include the toolkit. Before we install the coupler onto the idler, take a look at both parts. There are 4 screw openings that must line up. Orient the couplers. 2 grub screws are oriented as it. So our grub screws should be clocked at like 410 out. So we want to make sure that we line up the 4 holes for our coupler, that our grub screws are clocked appropriately. Add the coupler onto the side of the idler in a way so that all 4 screw openings line up. They do. Before proceeding, make sure the M4 grub screws are oriented. Picture. They do. Okay. Got the 4 screw holes lined up, and our grub screws are lined up the way they should be. We're going to fix it with the 4 M3 by 10s, and these are going to be threaded directly into the plastic. So grab our 2.5mm driver, start screwing these in. And I'm not going to screw them all the way in. I'm going to leave them, a couple of turns from tight until I get all the screws in. And that makes sure that I get this centered with the holes. Hey, Creatix Brit. Long time no see. How are you doing? I'm doing good. I am loving the new Polymaker education videos. That is amazing work. Please keep that up. Awesome. You just ordered a new computer? Great. That means you should be online streaming again soon. Huh. That'll be cool. Yeah, I need to get back to Dio and I need to get back to um Chopper. I need to start doing the body prep work on Chopper so that I can get him painted ahead of time so that when we start assembling him on stream, he's already at least painted. I may do some little video clips on that process, but I'm not going to like sand and spray paint on. Yes, very awesome. Maker Mind. Phone went silly. You're just hanging out on the backyard with the doggos, and that's awesome. Let the doggos run around and be puppies. Um, so now that I've got all four of these started so that they're aligned with the holes, remember we're going into plastic. So as you tighten these down, tighten them until you just feel the tension change. And that tells you that you've bottomed out against the part. Stop. If you continue to try and quote unquote ugga dugga these down, you will strip the plastic and you'll be reprinting parts. If it's on a thin piece of plastic, you will break the plastic and you'll be reprinting parts. So that's now in there and good. Let's see what the comments. People are just asking about the parts. So every part has a number on F1. All that means is there's a new revision. And I want to say if it's an R, like an R1, it's the revision that you've downloaded off GitHub and printed your, like a completely different number scheme for the parts that people print themselves versus the ones you get in the kit. And when you get the parts in the kit, I think you can get, not sure if the MMU you can get in different colors or if it's just the all black always for the, but before you proceed, check the following. All M3 screws are tight. Grub screws are oriented properly. Once again, we're going to look at those grub screws up at the, say, the 10 and down at the 4 position. Um, they're not protruding into the center opening of the coupler. I did not put them in all the way. The grub screw orientation is important so that the screws remain accessible even after the idler is installed inside you. Repeat that. Orientation of the grub screws is critical so that you do not limit yourself later on and wind up having to take your MMU completely apart if you need to get to these. All 5 bearings are able to rotate. Yes. And the 6th bearing is flush in the surface. That is a yes. Now we're done with this part. We're just going to set it aside. We're going to start the prep for the idler body. And that is going to be this piece here. Put that down, move a few things over to the side. So we're going to need the idler motor, the one with the short shaft. Grab that out of here. The one with the short shaft. The idler body, that. M3 by 10 screws. We'll need 5 of those. So our M3 by 10s. 5 more of these. Five of those out. Need some M3NS. So these are the square nuts. Need one of those, silicone stopper, and one of the shafts. So 3NS. Silicone stopper was over here. And another one of the shafts, which was sitting out. Okay. I like how they lay everything out. It's all nice and neat. And also, just to be on the safe side, did get their motors marked with the Prusa logo, but it also says idler. That helps you really come to the, realize that you got the right one or the wrong one. Hey, Donair, how's it going? You're installing a 1 to 5 XL toolhead upgrade kit. Oh, okay, okay. So you've got an XL one head and you're installing the other 4 heads. So quick question for you on that. When you buy an XL, even if you bought only the one head, does it come with all 3 power supplies already? Or do they ship you the extra power supplies when you get the additional tool head? I think one runs all the electronics, one's dedicated for the bed, and then the other one actually provides enough for the rest of the tool heads, correct? Spitballing here. Okay, cool. Yeah, that's what I would figure. It makes it a little more sense that way rather than sending people PSUs that they don't use but will consume power. Um, okay, so we're going to orientate the body is shown with the hole off to the one side. We're going to insert the silicone stopper into the small opening in idler body. Again, if we need to, we can click on that button and it makes the thing bigger. So we're going to take this stopper and it's going to go into this little hole over here. Stopper in. Silicone rubber stopper into a hole and says no. Wishes. May take a bit. Work it in. Like, seriously, it. So there's a little nub into that stopper, and as I try and push it in there, of course it's silicone, so it just kind of squishes instead of going down into the part. See if I can't get it worked around. Not really. Might have to. Try and help it. We'll see what comes next. Push it in and keep. Oh, there we go. Insert the stopper in the small opening in the body. Push it in and keep it pressed with your finger until you feel it fully engage into the opening. Doesn't engage, try cleaning up the opening with an Allen key, rotating the stopper while inserting. Okay. Up the opening with an Allen key. I don't think there's anything wrong with the opening. I just think it's like I said, a tight fit and a stopper that kind of squishes. There we go. The rotating helped. Rotating helped. Trying to do a stopper. Verify it's seated properly and won't fall out. Just did. Be flush. There should be bottom part of the stopper visible from the. So hard to tell on this printed part, but yes, it is correct. It is correct. So we're going to insert the idler into the body. Correct orientation is important. Make sure the middle bearing is pointing to the top, and sure the metal coupler is pointing to the large opening. Got the large opening here, which where the motor is going to go in. So when we put this in, we want our middle bearing facing up, the coupler facing that hole. To fit down in there like this. Okay, and there are kind of grooves there that the bearings will line up in because this is going to rotate in the housing. So push the idler to the left so that there's as small a gap as possible. Okay, pushed. Center the shaft assembly. Hold the idler in place with your hand and keep pushing it to the left side. Insert the 5/16 shaft in the opening on the left side of the body. Push it all the way through. Okay, so this is where we're going to take another one of our shafts and we're going to push it through that hole in the body. So let me get my shaft lined up and push this all the way towards us, making sure that we're lined up with bearing up. And we're going to grab one of our rods and push this shaft in. Okay. Where we're at, that shaft is now pushed in. So we've got this rotating area here. Make sure that we were pushed over as far as we could. So good there. Lock the shaft in place by attaching an M3x10 screw into the marked position. Once again, we're going to take one of our M3x10s. We're going to put it right down here in this bolt hole, and it's going to be screwed directly down into plastic. And the head of this screw is just going to block that shaft from being able to back out. Okay, so once again, go down until it bottoms out, no more, and it blocks that shaft from back out. Never need to take this fully apart. You've got to pull that screw out to be able to get shaft out. Okay. Then the M3N square nut, the idler side. Insert this in marked opening on the air. Take this in. Use something to push it all the way in. Make sure that it lines up that hole. You can see go all the way through. Thanks for the follow, Giggy Jack. Welcome on in. Welcome on in. So right there, we push that in all the way. Now we're going to take our motor assembly. Before we add the motor to the assembly, we need to align the motor shaft to the idler coupler. Notice there is a flat part on the motor shaft. So wires are going up. There's a flat part on the motor shaft. Right now we're going to get that pointing roughly to the top. Orient the motor as shown in the pictures so that both the flat part of the shaft and the cable are pointing up. So pointing up, flat part of the shaft is now pointing up. Before you start installing the motor, the flat part of the motor shaft must be aligned with one of the two grub screws in the metal coupler. Orient the coupler so that one of the grub screws is pointing. Now telling us to rotate our coupler so that one of the two grub screws is pointing. Rotated the coupler. The grub screw is now pointing up and down. Grub screw is now pointing up and down. And we're going to insert the motor shaft into the metal coupler on the idler, push the motor towards the idler body and flush. So now we'll slide this into the idler body. Should go all the way until we're flush. That's what we're looking like. Insert two M3x10 screws in the openings marked. Start the threads so that the screws engage into the motor, but don't tighten them all the way yet. Okay. Apparently easier. Yeah, getting in there. And I may need my ball end wrenches for this, so go ahead and grab those and bring them over. I know me. Knock these over at least 3 times while we're on stream. So we've got those started. Turn the unit around from the opposite side and another 2. So need to do 2 from the bottom. Make sure the screw is perfectly perpendicular to the motor while tightening. If it's hard to turn, release the screw fully, realign it, and start again. So we take this and we just flip it over. We're going to come in from the back side here with the other screws. So screw in there. And once again, it should just be very easy to screw in. If it's hard, then you're not properly aligned and you could wind up cross-threading the screws, so be careful. That's in there. Now tighten the first two M3x10 screws fully. Oh, and it does say to tighten these fully up on the bottom, so we will go ahead and tighten them with all the ugga-duggas. Those two are done. Now we're going to come up here and do these two. Applying some ugga-duggas. Idler motor assembly. Pull the idler to the side all the way away from the motor. Should be just a very small gap on the left side. So it's basically saying push it over to the left. Should be just a very small gap. What we've got is the definition of a very small gap. Make sure the grub screw and the metal coupler are still aligned to the flat part of the motor shaft. Tighten it up fully using your 2mm Allen. Try and use your flat end, not a ball end, when you're doing these screws to prevent them from stripping them out. Slowly apply the ugga-duggas. Secure the grub screw and the metal coupler. Rotate the idler so the second grub screw on the metal coupler is accessible. Tighten that one. We're going to rotate this around. Bring the other one straight up. Or tighten this. Just for giggles, I am going to tighten that because didn't feel like I needed to do any ugga-dugga on that. Just want to make sure that I am fully flush on this and centered. The reason you go against the flat first and then the round side, you go around the round side first, won't be aligned, we'll say, on the center of the shaft. You'll be off a little bit, which will cause a wobble in your mechanism. Right here, you're going to kind of see how it's going to move from position to position to align one of your bearings against the drive gear. This is how you select which filament you're going to be printing with. So this stage is now done. Move on to the selector assembly. We're going to take this piece, set it aside. So now got two little subcomponents done. Actually, a subcomponent, two pieces put together now. The selector assembly parts preparation. We'll have the selector assembly itself. A 10x6x2 magnets. So that's our magnet. One of the magnetic steel balls. My magnetic balls out here. You know, always good just to put it right there, and that way we know where it's at. When upgrading from the MMU2, ensure to use the new ball provided in the upgrade kit, not the old one. That means it's probably a slightly different size. And the new ball is made of a ferromagnetic material, which means it'll more reliably attract and close. Paubles are good, but not in our printer. Exactly, Britt. Oh, speaking of which, give me 1 second because I hear the Mark IV over here is silent. So let me come over here and pop a couple of prints. like I said, Miss Dragon wanted to make some cookies. And so I have been using up some scraps of Pet G, but this was a design by my logo put into the CookieCAD cookie cutter design software. And so we've now got some Dragon logo cookie cutters that we can use to make cookies. So, yep, there you go. Wobble, 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 wobble. Yeah, we've got a couple of cookie cutters here for Miss Dragon to use later tonight. I printed these in Pet G, and I'm going to consider these single use. So that means that you flour them, you cut out your cookies, and then when you're done, toss them. The problem with FDM prints is the gaps between the layers. So if you can run your finger over something and it makes that noise and you can feel where it's catching your fingernail, that means you have lines and ridges print, which everybody's going to. And you'll never be able to get clean all the bacteria out of it. So use them once, throw them away, print new ones. It's the best and safest way to do it. Okay? So we've got the magnet, we've got our steel ball, and we've got our idler piece. We're going to insert the magnet in the mark selector opening. So we figure out how they're holding it. So they're holding it in this orientation, and that magnet's going to go right there where the circular depression joint is, where we're going to put the magnet. So we need to take our magnet out. We're going to insert the magnet into that slot. Shouldn't matter which orientation, I don't believe. Yeah, the orientation of the magnet doesn't matter. They're in the thing. So we're going to insert this until it's flush with the surrounding surface. So flush and flat here, kind of where it's sticking out in the back. Okay. We're going to insert the magnetic ball into the hole, which is top. So insert that, click, and there's the ball magnet. Ball touching the magnet. Okay. And stay in place. If not, verify you're using the correct ball. It's staying in place. Exactly. Exactly, Killer Dragon. Once again, the note is the selector ball from the old one will not work. Now, here's something I'll show you while we've got everything opened up. So, filament, right? This hole here is the filament path. This is part of your filament sensors. Notice, filament will go in, filament goes in, and you'll see that ball raise up. This is how this will be the sensor for letting your MMU know that filament is loaded into the selector box. Extracted, filament loaded. And we're going to do a very similar thing to the top of the printer part, the extruder. Now we have the trapeze nut part preparation. Trapeze. It's a trapezoidal nut. We're going to need the trapeze nut. In case you're assembling the unit from scratch, the nut is inside the motor kit box attached to the selector motor. Well, that's good. That means we'll come in here and we'll look for which one of these has the trapezoidal nut on it. It said it should be connected to the selector motor, which motor? This selector motor, trapezoidal nut. We're just going to take this palm nut off. Probably going to leave the selector motor out because I have a feeling we might use it here soonish. By the way, Britt, powered by Duncan. Heaven forbid if I ever get sponsored by Duncan. So we need our trapezoidal nut. We'll need 2 M3 end nuts, which are our hex nuts. 2 of these. And no, let me rephrase that. 1 hex and 1 square. 1 hex, square, hex, square, 1 M3 by 10. 2 M3 by 10. Insert an M3 nut into the marked opening in the selector just below the magnet. Push it all the way in. Make sure the magnet doesn't get pushed. Okay, so this goes in the X nut spot right. So one of the easiest ways to do that is going to be to take a longer screw and press it down in there. So grab another one of our long. And kind of wedge it a little bit to be able to get it underneath the it. Push it all the way down in there. Bolt. There we go. Down in there. Insert the square nut, marked opening on the other side. So flip to a different picture. Come over here and looking at it from this way, it's going to go into this. Where it gets pushed all the way in and lined up with the holes. And that's going to be the 2 screw points for our trapezoidal nut. We're going to attach the trapezoidal nut with the flange sticking out and proud of this. Line up the holes with our 2 nut openings. We use our M310s. Tighten them just slightly for now. We'll tighten them up fully later on. That's because we're going to need to set the, say, like the backlash of this nut to the on the shaft. Trapezoidal lead. So just there, I just barely snug those so that we're connected. Nothing's going to pop out. Nothing's going anywhere. Well, good. Yes, that is true, Britt. So you could do cookie cutters like the other ones I did were dragonflies, but here's an educational video. Print out cookie cutters of different animals and use those to cut out Play-Doh so that you can make, different animals, maybe in different Play-Doh colors so they can learn the animals and the colors at the same time. There's a thought. Yeah, I need to get Mrs. Dragon on that new Polymaker education stream because her being an early childhood special educator, I'm sure there's plenty of stuff that she. So we're gonna need our other two, need our two bushing, fun. That leaves a ball and another little silicone bushy point. Got our two bushings. Gonna need two square nuts, two more M3x10 screws. Oh, definitely. Definitely. I will get her reached out to you listening right now, which I don't but yeah, definitely. And we're going to need this part here as the selector front plate with the screw and bushing arm. So we're going to assemble the selector, taking our bronze bushing, we're going to fit them in these holes. These holes have these slots cut in them that allow for a bit of compression. So as you push these in, it will allow the pet G to kind of give a little bit, but still compress down on these. Make sure you're inserting them from the correct side. Good thing I got lucky there. Inserting them from the correct side. Two, and get them in by hand as far as we can. Isn't very. Press them carefully, pushing the assembly against a flat surface. Or if you've got an awesome benefactor like I do in KB3D Chris, and he sends you a set of Nipix pliers, rather than chancing marring your desk, you can take your Nipix, get them adjusted. You can use the flat-faced Nipix pliers to press in your bearings. We'll take a couple of cracks at this because we're going to have to go slow. And you don't want to break your part, so take your time, go slow. Almost there, got a little bit more to do. Take it one more step up on our Nipix. Final squish. This will make sure that it's nice and flush with both sides of the part. in. And there's our bushings pushed in. Tell you what, these Nipix pliers, like ever since I got them, I think I have wound up using them on every single build, and I love them. So give me 1 second. Sorry, I was telling Mrs. Dragon to join the stream and reach out to you, Creatix Brit, before I forget. No, but it's one of those things that Brit is working on ways that 3D printing can be used to aid with education. And Mrs. Dragon is a early childhood special education teacher. So yeah, it's amazing the things that you can use to print things out. Like we were saying, you could print out some cookie cutters and use them in the classroom to cut out shapes like animal shapes or what have you in Play-Doh. So now you've turned a single lesson into a multi-lesson where you can do math, you can talk about colors, you can talk about the animal. How many do we have? What colors are? How many of what color? And talk about the different animal shapes or whatever shapes you're cutting out. Um, it's amazing the simple things that you can do with very few materials to come up with stuff. Hey, Ash Prince, how's it going? Yeah, I love those videos. So we're gonna have to get Mrs. Dragon uh, hooked up with it. The end should be flush with the surface on both sides, which it is. Good there. Uh, rods and cover. Insert two M3. Okay, Mrs. Dragon. Yes. So I need you to reach out to Creatix Brit. She is now doing a Polymaker education stream, or not a stream, but videos. And I need you to connect with her on Twitter, Discord, the whole 9 yards, because she could really use some some additional ideas on ways that 3D printing can be used in the classroom. The suggestion I had was I was just showing the dragon cookie cutters that we just finished printing. And the fact that you could take cookie cutters and use it with Play-Doh in the classroom and be able to cut out shapes or animals, and then you can turn that into a multi-tenant lesson where you're you're learning colors, you're learning the animal shape, you're learning to count, and just one piece can be used to do so many things in a classroom. So yeah, definitely need to get you hooked up with that. Okay, what are we doing? Okay, we're inserting our two screws into these slots in the front plate here, or not screws, our two square nuts. So those inserted, and you might have to push them the rest of the way with a smaller Allen key. Normally says to use a 1.5 to get in there without marring the surface of the print. Make sure they're fully popped in and engaged. Add the front plate onto the selector. Make sure the side of it is flush with the flat part of the selector. So we've got our nuts pushed in. We're going to take our selector plate and line it up with the holes so that the flat edge, so you've got a flat edge and a sloped edge of the selector. sloped edge, flat edge. Flat edge will go to this. So then we'll take 2 of our M3 by 10 screws, all these. Tighten them up. Britt, you've done the MMU on your Mark III, Mark IV. There's our selector put together. With following steps, please prepare the super fenda, M3 by 10 and an M3S square nut. Mark III, yeah. Okay, that's what I thought. Ah, square nut. 3 by 10. You see me continuously closing these bags up. That's me. I know myself. I will knock one of these over or drop it if I'm not careful. And we're going to need our super fenda, which, interestingly enough, is a super penda. It's the same exact thing. It's just used for a different purpose. So it's the same exact sensor, just used for a slightly different purpose. There we go. So we're going to insert the nut into the marked slot. In that case, it's going to be this slot right there. And add brake in progress. Push this in. Lined up. And then you're going to insert the super fenda to the corresponding opening. So we're going to take the super fenda and put it in. Here the sensor's bottom part is aligned perfectly in the D-shaped opening. So there's a D-shaped opening here. That's what we're going to use to align it. This is going to be a good starting point, and I think what they're trying to show, click this and make it a little bit bigger, is that the fenda should be flush with the flat side of that D-shaped opening. So we're just going to take our sensor, put it in, and here's what I'm going to do. Wait on the ad break for sure, but I'm not going to worry at this point about getting it right in that spot. I just want to make sure that when I tighten the screw, that it's going to be nice and flush, and that gives us a starting point for adjustment. Okay, folks, give me 1 second here. I need to blow my nose. Okay, sorry about that. So Britt, I can tell you that she is on Twitter. I believe she's on my Discord. But she doesn't like stream or anything like that herself. I thought she was on Discord. If not, I can get her on Discord after this. But she does have Twitter. DM her on Twitter. pass any information, set up any. Yeah, we can definitely. I thought she was on Discord. Apparently not. We will remedy that. We will remedy that. Okay, so what we want to do is line this up so that it's right at the flat of that D shape slot, not fully in, not way out. As I mean, it just flops around right now. As we start to screw this down, I will do that alignment. That's going to provide the initial alignment of our sensor. We will have to adjust it, fine tune it. But for now, we're just going to start to get this clamping down. Then we'll pull this down into place, get it nice and flat. So once again, this still turns around, still moves up and down. We're going to line the head of this with the flat of the D and clamp it in place. See it right there, top shot. That's where you want it. Might be just a hair proud, but like I said, we're going to adjust this um, as we work on it. Or as we get it installed, we'll adjust the height of this probe to make sure that we get reliable triggering. So next step, fix the probe in place with an 3x10. Now we need an M3S nut, M310 screw. Yes, you can send a message in Twitter. So, yep. We've got our square nut, we've got our screw, and we're going to need blades. And then our other printed part, which would be the blade holder. This part, not sure if you can tell yet, got the little ridges on. It's going to be used to hold the blade in place. We do have blades. We've got MMU3 we do have a couple of different. It says MMU2S, but I'm assuming it's the same. Two stored in a little plastic box. Be careful when you're hitting blades. You might easily harm yourself. That is very true. So we're going to insert the M3S nut into the top slot right here by the selector. Which, ooh, a little bit harder to get. Hard to get in. Don't do like what I was trying to do and just shove it in. Grab your razor blade and just try and clean out the hole. It's probably just a little bit of overhang in the hole. Just use your blade and or a pair of tweezers to try and clean out the hole some. If it's still hard to get the square nut in, then I'll say do the other next best thing, which is grab a different square nut. See that that square nut has a slightly thicker tolerance to it. So they're pretty good with getting good supplier with good tolerance. That one went in a lot easier. All the way in, up. Thanks for the alert, Britt. Got alert. Got to go do mom stuff. Good luck. Nice. Mom stuff and dad stuff. That's always good. So we've got the nut installed. Now we're going to take the two blades, and they need to be lined up in a specific manner. So it's on this side of the printed part, and you can just see the shape that's made. So we need to match up that shape carefully. So grab a set of your blades. Carefully. Um, and the blade edge point will come down and join in the middle. Get these lined up in there as straight as possible. Careful not to stab yourself with the blades. There is it is definitely a guided printed part. Should line everything up perfectly for you. So it shows them coming together, but there is, at least in my printed part, little sliver down the middle that gives them slight angle. Weird. They are close, but not perfectly. Version A, version B. What do we got here? There's been several versions of this part available which might look slightly different. However, the assembly process markings on the part may be different from the one seen in the photo. So we have that, it looks like that version B where it's slightly at an angle and the blades are slightly separated. So we've got this version. However, the plate with the blade holder verify the blades are still seated perfectly in place while attaching the cover. Got our cover here. It's going to attach. And once again, we've got these two little raised areas. It's like one layers. That's going to help hold these blades in place. So we put this on, we just need to make sure that the blades themselves do not move. reason my screw is not catching. Catching the nut. There we go. So I'm making sure that I keep this part straight, not rotated. So I'm holding it on both sides as I'm clamping it down. And I'm watching the blades to make sure that the blades do not move. Plug this up. And you'll notice that the top has like a little lip, flips over the top. And that there's a little like not cut, in the printed piece itself. There's a little notch right here. This is the hole that the filament comes from. Notch. There's the pointer that says filament's going to come out of. And what'll happen is it'll take your filament so your filament's in there, and it's going to slide the selector across, which is going to force your filament to get caught, bent over where the blade cuts it off. So that's your filament cutter. Be careful, you now have an exposed blade tip there. Got to be careful and be aware of that so that you don't catch and hurt yourself. Fix the blade holder in place, tighten it up fully. Once again, you're tightening here, but you're making sure that that cover stays in place. Your blades are seated, and that you don't get a twist in this cover, and the blades don't get moved out of whack. That's done. Little blade holder and not anymore. Done. We're on to the next step. Looks like we're going to start putting the pulley body assembly together. So once again, we're going to need tools. We're going to need another big piece to be in this bag here, which is the pulley body elements. I'm going to make a mess here getting this stuff out. Okay. That over there, we'll bring these things out of the way. Okay. So we're going to start with our main pulley body element. And we're going to need 3 of our bearings, which we'll have 3 of our bearings here and 3 of the shafts. Doesn't talk about the shafts yet. Got them. So looking at our part, we've got the 2 holes here, 1 hole over here. So looking, and it wants us to insert one of the bearings marked openings. This in here. Clutch. Insert the bearing, the second bearing into the groove on the opposite side of the puller body. So turn the part around. Got another spot for a bearing right there, so we'll put another one right there. Done. Insert the third bearing into the mark groove on the inside of the body. So got these 2 here. We're going to have a marked groove So this one, and then get pushed down in there. Fits all the way down in there. We push that one in place. Dropped into the bigger slot here, and then kind of wiggle it down in there and pop it in. Okay. Now that's enough of that part. We're going to grab this other part, which PTFE holder, yep. Need 4 of our square nuts. Square nuts. 4 M3 by 10 screws. And 5 pieces of 19mm PTFE. Seven PTFE 19. PTFE out of here. So we're going to insert the 4 M3 NS nuts to the marked openings of the idler body. Idler body, we've got 4 spots for nuts. So those 4 right there. Make sure that these are fully up and seated down in there. They need to go way down in there. Down in there. Lining up with these holes here. Now we're going to insert the 5 19mm PTFE tubes in marked openings. Small chamfer on one side of the tubes. The chamfer should be facing out towards us. So we're going to look at each of these tubes and look for the edge. Bit of a foot. So the chamfered edge is facing out. Going at the top edge here. These do not go all the way through. There is a stop. These put in. Got all 5 of those put in. Now we're going to attach the front PTFE holder, this piece. Push it all the way towards the pulley body. Mind the correct orientation seen in the picture. So looking, there's that needs to be facing up. 5 holes at the top, that's for the PT. 4 holes at the bottom, that's going to be for securing this in against the screws. So the longer angle side goes down, shorter side goes. These up on our 5 tubes. So here's an interesting part. Could be tight, but they could be a good close fit. They're really, really tight. Trying to get these pushed in, and I don't want to damage these PFE tubes. So if we need to, we may want to open these holes up just ever so we don't crush our PTFE process. So these holes should be 4mm because they are for a 4mm PTFE tube. So we'll grab our 4mm whatchamacallit, our 4mm reamer. Don't want to use a drill, we want to use a reamer. Come in from the backside by hand. As long as I can get it done by hand, I want by hand. See if there's lots of comments. Definitely seated all the way back. Full tolerance. Slight imperfections. I am going to open these up once again with a 4mm. Make sure I've got the I'm just going until I see the bit peek through the hole on the other side. Because the way the bit's chamfered, it should leave just a little bit of extra compression fit at the ends of these still. But because this is reverse Bowden tubing, I did not want to try and compress these in there and force them in, because then we could have issues with kinking tubing. So once again, now that I've got them all in there, second to this other, that's the way it's going to go. It provides a good channel through this printed part. It's kind of hard to tell, but there are little right there. Push this all the way back, you should be if you go into that window. So we cleared these out. We've clearly got the PTFE all the way to the end. Now we need to take our M4 screws and screw this together. So now that we've got it there, we'll use the M4 or the M3 screws to screw this whole piece together. Once again, this is nothing more than, once again, it's printed parts, tight tolerance printed parts. Every once in a while, you know, the glue gun over extrudes, you know. They have to go in and open some holes back up. Not that big of a deal. It's natural. So there we go. We've got our 4 bolts. We've got all 5 of our PTFE line tube halves now. Comments up. We're going to need this printed part. Just the collet holder. 2 M3 by 2 nuts. These would be the hex nuts. Two of those, 2 of the M3 by 10 screws. Imagine that. And 5 of the collets, which are in, oh, what are these other bags? Five collets. Okay, so we've got everything prepped and ready. Take the collet holder, note the correct part orientation marked by the imprinted arrow. So we've got the arrow that's imprinted on here, and we're going to say that's the side that we're going to hold it on, which means all of our collets come in this side. These should be press fit, just press fit and pop right in. Apparently that's two of them that I've broken one of the legs on. So two of them that might not hold as well as they should because I got ham-fisted. I think I've got a few of these, so if I need to swap those two out, I can. Should still be good. Feel of it. We've got our 5 collet. Might need to squish the fins on the collet with your fingers while you insert the collet. This will click in easily. Yeah, it clicked in real easily. That on at least 2 of them, I broke one of the collet or one of the fins off. So we'll see. If I need to, I'll replace 2 of these. Back over to this piece. Insert 2 M3 nuts to the marked openings at the bottom of the pulley body. Push the nut all the way in. So this is going into the holes here. This is where we once again might need to take one of our larger screws, in this case an M3 by 30, thread it onto the end of our nut and push these down in. Back the bolt back out. That should stay in with no problem. Do that for the other one as well. Oh, should have your 2 down in there. See, with there are 2 M3 down there now. Line up right here. So we're going to attach the collet holder to the pulley body. Note the correct part orientation marked by the arrow. Once again, the arrow is providing the direction going this way. It's going to fit right down in there, and we're going to put in our 2 M3 by 10 screws. All right, Killer Dragon, enjoy your day. Okay, we're just snug those up pretty good. There's our collet opening. As you can see, flip this over. Wait, we'll have 1, 2, 3, 4, 5. So show us the pulley motor parts preparation. That's the selector motor, pulley motor. We need the pulley motor, so we need to grab that out of here. Don't think there's anything else in here. Okay, so we've got our pulley motor as requested. We'll have our drive gears. So we need 1, 2, 3, 4, 5 drive gears. And by the way, we do have a couple of extra collets and a couple of extra 19 millimeter um, pieces of PTFE. So we do have extras, which is nice. We need 3 of our square nuts. And of course, 3 more of our M10 screws. Orient the motor as seen in the pictures. Here the motor cable is facing to the back. So I'm going to kind of lay this down on here in the way that it shows on the picture. So the shaft pointing towards me, our wires are coming out the back side here, and we want the motor shaft facing up. So wires coming this way, motor shaft facing up. Rotate the motor shaft so the flat part is facing up. Slide the first pulley onto the shaft. Sure the lock screw is up facing the flat part of the shaft. Tighten the grub screw just so it goes in with the drive gear. So the filament drive gear is facing the motor. So the filament drive gear goes in first, and that screw is a little bit too far down to let this go on there, so we'll back that off just a tad bit. There we go. Now, here's the worry that I don't know if these have Loctite on them already. I know from doing other printer builds as well as doing a previous MMU, you want Loctite on all your grub screws. These grub screws do not have Loctite on. Put Loctite on your grub screws. Okay, Liz. Understand that. I did that myself earlier today. And if your Loctite is semi-hardened like mine is, don't be afraid to open up the new stick that you. Doesn't take much. And right now we're just getting these on there. There's not going to be a dedicated position just yet. We'll position these once we do the next step or two. So just get your gear motors on there and give some Loctite love to your heads. Just barely getting it on there. I'm not trying to ugga-dugga it down. Just wanting them snug so that they can still move a little bit. folks, my plan was to stream for 3 hours. So at the 5 o'clock mark, I do plan on stopping. Um, we'll resume this back on another stream, but this is just kind of an impromptu stream thrown into the mix because, well, I was off work today and have anything else better to do. So stream it is. I say that. There was other things better to do, like yard work. However, it stormed like crazy this morning. Rained some last night, and then it stormed big time. Okay, so got all 5 on there. They're just back to back. They're lined up with the flat. Um, we're gonna slide all the other pulleys onto the shaft using the same technique. Tighten the grub screws slightly for now. We're just trying to prevent them from sliding on and off as we do things. We'll figure out the position in a little. We're going to insert, we're going to cap our stuff so it doesn't out. We're going to insert the nuts in marked slots on the pulley body, push it all the way in. So on our pulley body, there's a slot right there. And sure it gets pushed all the way in. So it lines up with that hole right there. What? Orient the motor shaft so that all the grub screws on the pulleys are facing. Yep. Wires to the back. Grub screws are all facing up. Here the motor cable is facing to the right, to the back of the MMU, which is where our little pulley area is. Insert the motor into the pulley body as shown in the picture. Make sure the motor shaft engaged into the bearing at the end of the groove. So just as we see here, all of our motors are going to slide in. I'm going to slide this in, and it's going to engage in the shaft at right. And as you can see, our things are nowhere near a proper alignment. And our shaft is in the bearing at the end. Attach the motor with one M3x10 at the top. Turn this around. We're going to attach it right here. M3x10. Sure, it's perfectly perpendicular to the motor. If it gets hard to turn, cross-starting, stop, back it out, try and redo it. Now we're going to flip everything over. And we're going to do 2 in here at the bottom. This is where we're probably going to need our ball end. The hole, push it in. reason it feels like it's not lining. Do that and twist it into what it was. Screw it in place. It's completely. Just tighten these up fully, so we'll go ahead and fully tighten. Come back and tighten this front one. Okay, and now this step is crucial. We want to go through and align all of these in the proper to line them up with the filaments. So we'll crack the nut, pull it back. We're going to line it up with each of the filaments. Tighten it back down. So we're lining it up directly with this filament. There's going to be a slight gap between the various drive gears. Here we go. Each one is lined up with the filament path. And you can, as you're doing this, you can take filament. Let's take a perfectly straight piece, okay? Run your filament through the channel, and it should line up with that drive gear. And that's how you're going to verify each one of these. Run it through your drive gear. In my case, I don't have a quote-unquote perfectly straight piece of filament because it's an older piece, but as you push it through, you'll see that your gear is perfectly lined up. If not, now is the time to make any adjustment. And mine is really curved, but as you get it through both sides, you'll be able to see whether or not it's up on. You want it as centered as possible on all of your gears because that will give you the best bite. This is the only gear that will be engaging with the filament, so these teeth need to be lined up because the top portion here is going to be that 625 roller bearing that you apply the pressure. So with each one of these lined up, we're good. Be able to keep going now. Lining it up, knocking it down, really doing each each one. Now we have the selector part preparation. Gonna need selector assembly that we had prepared before. We've got that. The selector motor, that. 5 120 shafts, 2 5 by 120 shafts. Got those right here. 2 M3 square nuts. Yep, we've got those. 3 M3 by 10. There's those 3. Okay. Insert 2 M3 NS nuts, marked openings, pulley body, push the nuts all the way in. So on the pulley body, we need 2 of these nuts. One's going to go up here. Sure it gets put all the way in. Oops. Or I'm sorry, not here, through the front face. That's where the screw's going to actually try and put it to start with. Here. And one down here. And make sure it's fully engaged. Okay. We're going to insert the selector into the pulley body as seen in the picture. So here's our pulley body. We're going to take our selector and our collet piece faces out. So it's going to sit in there like this. We're going to insert the 2 shafts through the marked opening, which is top and bottom of the center hole here. Center hole, we want the top and the bottom. Going to go into the bushings on our selector, through the selector, and it's going to bottom out on this side of the shaft over. Make sure that they're pushed all the way through. Just like that. Okay, so looking like we push the shafts in until they're fully inserted slightly below the surface below the surface. Verify the selector can move around freely while the rods are in place. So we're just going to slide it back and forth. Selector moves quite freely. Insert the selector motor so that it has the trapezoidal shaft goes through the pulley body. Sure the selector motor cable is up before you proceed. So motor is facing up. We're going to put this in, and it's going to engage in the trapezoidal nut here. And then we're going to basically just twist the selector on. Rotate the threaded rod. We'll push towards the selector to engage the trapeze nut. Continue rotating the knob until it passes entirely through, leaving about 2 centimeters on the other side of the selector. Keep going. Okay. Sure that the selector motor cable is orientated upwards. It is. Then push the motor all the way in. Check there is some clearance between the selector and the end of the travel on the left. There is a bit of gap over here. So we're going to attach the selector, push the motor all the way in. Wires are up. We're going to attach the selector motor to the pulley body with 2 M3x10 screws in the marked openings. So we're going to go this one and back one, I believe. This hole, one in the back. Tighten them up using the ball end Allens. So we do want these fully tightened now that we've got them both started and aligned. So it should align up all of the holes. The last M3x10 screw to the corner. Tighten it snugly. Do not over tighten the screw this corner. Otherwise, you might tilt the selector motor. In other words, we might cause a bind in the selector motor. Put it tight, not over tightened where we could bend things out of whack. Make sure that as we rotate things, everything moves easily. Using the ball, using a ball end, slightly loosen the 2 screws holding the trapezoidal nut to the selector. Don't remove them completely. We're just going to loosen these 2 screws. Okay. Trapezoidal nut. Verify the selector can move when forced left or right. There should be no hiccups along the way. Note that you have to exert some force to move it as the motor has physical. Okay. Be able to move this both directions with no problem other than, having to exert some force. Then to move the selector all the way to the left. Good. Now we're going to physically retighten these 2 bolts. Now the idler assembly. The idler assembly, two M3, or excuse me, one M3 in nut, one square nut, two M3 by 10 screws, two of our M3 by 30 screws, two springs, springs, and two of our shafts. So, and attach the idler assembly onto the pulley body. Idler motor should be. So we're going to have our motor sitting here, the two on the right. Idler is going to flip over and flip on just like that. Okay. Now take a look from the opposite side of the. Okay. Looking at it from the side of the unit, we're on here. We got one motor on this side, two on this. From this side, we want to insert one of the shafts in this side. So we'll take one of our M5 by 16 shafts, get it started. Push it all the way in. Around and do the other one from the other side, same thing. So I have to lift up, adjust, move things around. Sure it's fully pushed in and seated. Now we should have a opening and rotating mechanism. Fix the shafts in place by attaching M3 by 10 screws into the opening of the pivot. So on our pivot joints, we do have a hole right above the pivot joint screw. This is just going to go in to prevent that pivot joint from sliding out. Screw it in until it bottoms out. Same on the other side. Just like that. Open the idler body up. And install the square nut, marked opening in the inside of the pull, push it all the way. So motor selector, this needs all the way to the end. Moving. Okay, so we need to put another one of our nuts in on this side. Would have been easier to install this at an earlier. Lined up. Gonna put the springs through our M3 by 30 screws. Hey, Glendon, how's it going? Glad you're doing well. Got our 30 M3 by 30 screws with the springs on it. Close the idler and insert the M330s into springs and marked openings. Tighten them. Screws are just above. Drop these down in here. And we're going to tighten them just until the screws themselves still above the surface. There we go. Now we got this wiring mess that is all over the place. We're going to take this and we're going to scoot it right over here off camera for now. That box. We're going to have a few spares here. Put a couple of things in here, like an extra set of blades, another gas shaft. Okay. What's up next? We need the roller box housing here and the roller board. Oh, here's the MMU controller board. Up. Okay, so not here, not here. These are all bags. Parts, parts, printed parts, other printed parts. The electronics in it. in the other box, so I hadn't fully gone through yet because it was all the buffer system. So note to self, look at all the boxes for everything that you'll need. So how's it going, Glendon? Hope you're having a good day. There's our nice new pretty board. Oh, need some 3 end nuts, our standard hex nuts. 3 of those. And some M3 by 6 screws. Three of those. So we're going to go ahead and press our hex nuts into the back panel here. Make sure you support it on both sides, or on the side or the other side as you're pushing it, because it's only held on here and here, so there is some flex to the part. If you're not careful, you could break your part. They're fully pushed in and seated down in the hole. Squarely seated in. Going to make it easier, especially with the M3 by 6 screws, to get hold of them. So down in there. Had a really good day. Had a cookout with my family, and my birthday. Oh, nice. Very nice. I'm going to slide in the control board. So know that you've got your lights and your push buttons. So this needs to be slid in so that you don't damage those. So slide on right there like that. And we're going to fix it with the 3 M3 by 6. Be careful not to damage anything on the board. Yeah, that would be bad. Maybe look, so very nice screen board. We've got some good silk screening. Steppers 1, 2, and 3. The Fenda power 9C. 3 stepper drivers with their associated capacitors on this side. All of these are LEDs for status indicator. I have a reset button right here. A USB connector. Yeah, very well made board. Very thick board. Well, slide this back in here, make sure everything is lining up again. Just like everything, don't tighten these down until you get all of them lined up, and make sure that they're all biting into their respective nuts. You tighten these down. Don't try and really ugga dugga it. You're This is a non-moving part. You're just trying to plug it and hold it in there. You don't want to crank down on it and crack it. But there's your board mounted. Of course, this is your main CPU on the board. Very nice looking board. Yeah, PD board parts preparations. This is the other board that we had. Was over here. PD is power distribution board. Got that. Need a cable. Appears to be in here. Sure if that's the right cable. However, that is the only cable that I am seeing. We'll assume for now that that is the cable of choice. Following steps, please prepare the MMU printer cable. 1. Mark 3S Plus version, first pitch. Use the correct cable for your printer type, Mark 3X or 3.5, 3.9, Mark 4. Note this cable is different from the old MMU2S cables. Don't use the... So, got you. That's the old cable. This is the new cable. This is the correct cable. Very nicely done. Already has the, this is drinkable. No, this is split lube. Split lube. Not sure what kind of connectors these are. Of course, very well made cables. 3x18 screws. You count. 3x18 count. And 3NS nut. Square nut. Board right here. And the board cover. So we're going to start. Take our board, slide it into gentle. Clear this edge. Is spring loaded though? Sprung it a little bit. So slide it home. That it's flush. It is PET G, so it does give a little bit. What I did was I basically pulled this edge over to allow me to get the printed circuit board in a little bit. Connectors a little bit further back. That allowed me to get it just enough to where I could Move it in. Snapped in pretty easily. Hey, Stephen Poole, how's it going? The PD board in bracket on the cover. Note the correct orientation of the parts. Yes, yes. Plug the board onto the leftmost connectors on here. Got this. These two DuPont connectors are going to slide down on these two connectors. And up just like that. And fit right in. See how that cover nicely fits in there, covers everything up, closes everything up. These two connectors slid right on, no problem. It does cover up this connector. I can't remember what that one was for, but I have a feeling it's anything. It look like. This is the case if you didn't have the cover, PD board would still slide in. It's showing everything. Connect the MMU cable to the. Okay, so your cable has double row on one side and a single row. The single row is what gets installed on our PD board. You only go in one direction. Plugged in. Don't connect or disconnect the cable if the printer is connected to the power outlet or is powered on, because this is your power distribution. You unplug this either end while the printer's on, you're going to fry something. Okay, now we need to double checking roll. Let me get Prusa stuff ready. Sorted. Guess it's coming up. So we need to get our two parts put together from an electrical standpoint here. So we move some things over, move the camera up here. Going to bring our MMU back into the picture a bit. Motors on one side, one on the other, so I'll turn around. Okay, we've got one motor on this side, motors on this side, fenda. So where the unit and the electronics. So follow the cables to plug them in the correct order. This is our fenda to the printer. We're just going to kind of pull this around and out of the way. Super fenda sensor cable. So super fenda is going to be the first connector here, a 3-pin. And it's keyed to go in only one way, and it should clip in and latch or lock, just like that. Super fenda is it. Next is the pulley motor. Double check which one is our pulley motor. Once again, the connector is keyed to only go in one specific way. So we'll add that, make sure it's properly lined up, and lock that one in. Next up is going to be the selector motor, which is the left rear motor back here by our pin. That one up and in. Means our last one should be our idler motor. Yep, that says idler. Pull this under. It. That's going to go in the last. So here we go. Fenda. The pulley motor, the selector motor, and the idler motor. There you go. And there's one that is not used, which is blocked by our power distribution one. So there, the electronics assembly. Now with everything kind of in this orientation, need to insert the M3S nut. 3S nut goes right here in this slot on the side. Push that in. Fully lines up. There's already one over here. Attach the electronics assembly to the MMU unit. So we're going to take this, just flip it over, pulling all of our cables out of the way. Everything should kind of line up. So look at the back to see if the PD cable doesn't interfere with the other cables. So our PD cable, see, these motors come over, this motor comes over, our fenda comes around. This one comes around, and this comes out here. It actually shows it being looped through this. Got you. So these cables should come over and not underneath. So like this, sort of, it is. Be good. I said this is showing going through that cable. I don't know if I actually like that or not, but this is basically how it's showing everything going. Fix the electronics in place with two M3 by 18 screws, one on each side. Here, here, it always has to be a pain in the butt. So the issue that I'm having here is the one screw on this side. I'll say the hole's a little fouled. Hey, oh, maybe not. Is that? Oh, it is going. Get this back in place. down, down. Okay, so electronics are mounted on there. Once again, we flip around to the front side. You'll see our motor wire coming around. This motor wire is coming around. Everything's neat. Um, this wire, like I said, I don't know. It's over time, this wire will get a little bit more flexible, but the only thing I'm worried about is, like I said, it showed this wire being looped through here. I don't know if that's really necessary, but this top part does rotate up and back. So it very well could go like that. Textile sleeve parts preparation. Okay, a textile sleeve. Um, so we do have one of those sleeves. Put it here. We've got the textile sleeve. We've got zip ties. Sure that the selector is fully to the left. We'll pull this all the way over. Make sure that the super fender joins the motor wires over here on the left. Leave enough slack in the cable so that it doesn't bend too much with the selector reaching even the first. So something like that. We'll put a zip tie on it. So stand up. Let me grab the zip ties. I don't know why I'm going to open these because I bet you I got a bunch of them still over here from a previous project. I'm going to use these if I don't have to. Got so many zip ties, it's pitiful. You made it back in one piece from your nap. That's good, Liz. Okay, so we're going to use a zip tie to join these two together, kind of right about there. We need to leave enough slack that our super fender could get there without any, without tugging or pulling this cable. So we'll join these two together with a zip tie. And then we're going to come around to the back corner right here, and we're going to add the other cable in as well and do another zip tie. In this case, we're just going to bring these three together kind of like that. Go ahead and snip this off. Wrap the MMU printer cable in the textile wrap if it isn't wrapped already. Hey, we got some textile wrap that we can use for other projects now because our cable's already wrapped. Fix these cables to the mark attach point on the electronics cover using a zip tie. So wrap the things in textile, join the idler motor cable with the MMU printer cable right side to the access through the electronics. Hey, Free Heathen, welcome on in, my dude. Welcome on in. Thank you for the raid and the 28 viewers. I'm going to ask you to give me 1 second, and then I will switch cameras and do an introduction. In fact, I'll change right now, but give me 1 second. I got to blow my nose before I sneeze again. Bear with me 1 second. All right, welcome on back, everybody. Welcome in Raiders from the Free Heathen Workshop, Pez Liz, 491 Phantom, Mayhem, the OG, Hobby Main, Blue Dude, welcome on in. It's good to see you again too, Blue Dude. I saw you briefly over on Free Heathen's channel right before I started streaming myself. Hey, Tech Jeeper. Bexy Beans, how's it going? Be right back because tired and late. Oh yeah, I get that, Bexy. I get that. So welcome on in, everybody. Thank you for the follow, Cruising Girl. So my name is Digital Dragon. I am a 3D printing variety streamer here on Twitch. For those of you that know, you know. If not, here's the spiel. I'm a 3D printing variety streamer on Twitch. That means that I do various things that are 3D printing related. Do everything from unboxing and modifying commercial printers like a Bamboo Lab X1, a Prusa Mark IV that's down here that we're doing a mod for right now, to full up 3D printer builds such as our Annex Engineering K3, prototypes such as the 0G Mercury 1. This is a one-off build based on a closed beta, to various Voron builds. Kind of hard to see. I'll switch cameras in a second, but down here we've got a VZBot 235 build that we're working on Tuesdays and Thursdays, and our black box build, which we're working on Saturdays. So a lot goes on. We also do 3D prints. I don't know, you might see some cool helmets around here. This is a Warhammer 40,000 Space Marine Chaplain's helmet that is all 3D printed except for the actual tubing, which is off of Amazon. These are fully wearable helmets. Just need to add some padding to make it a little bit nicer. We do have some Blood Angel helmets around here as well for our good friend Free Heathen, because we know he loves them so. But yeah, welcome on in, everybody. Welcome on in. So we've been working on our MMU2. Switch the camera over here. We've got stuff spread all over the place. Part of the, excuse me, not MMU2, MMU3 system. So this is a multi-material system that will allow you to switch between 5 filaments. So when we say multi-material, in this case, we really mean multi-color, because you don't want to be printing with dissimilar materials like PLA and ABS through the same nozzle at the same time. You will get nozzle clogs, most likely. This is really more multicolor than multi-material. And as I said, please excuse the mess. But we do have our black box printer over here. This is an actual tool changer. So what you will see back here is 5 different tool heads. Nice thing about that is you can do true multi-material with it in the fact that each tool head is a separate hot end with a nozzle that's at the right temperature. So you can print different materials out and maybe print like an ABS part with an embedded TPU hinge for a live hinge part, right? And then over here, we've got our VZ bot that we've been working on. Uh, so yeah, definitely join the stream. Definitely come out. We meet Tuesdays and Thursday evenings starting at 6 p.m. Eastern time and Saturday mornings at 10. Like I said, we've been doing the um, BZBot during the week and the black box on the weekends. And both of those we need to get done because both of those printers and the Annex Engineering K3 here are green and black print. We'll be going to the next show with us on June 21st, right? Out in Goshen, Indiana. Hey, Cruiser Girl, you've been debating between getting a Prusa XL or making a tool changer from scratch. Well, so here's the thing. You've got the Prusa XL, wonderful printer, fully supported by Prusa. You've got some open source alternatives like a stealth changer, which you can take a Voron 2.4 and make a stealth changer out of it. Zombie Hedgehog has done one of those and has several videos on Twitch and I believe on YouTube on one of those. But there's still some stuff being done right now. There's, I want to say he calls it the 8-track, which is another multi-material unit. It's not a tool changer, but it's a multi-material unit. So multiple filaments going into a single hot end. And then you've got the black box. The black box is an open source tool changer. It is now fully supported and there are fully configurable kits that you can get through KB3D. This kit right here did come from KB3D. He supplied the base printer. I have purchased all the parts for my 5 tool heads. I would say you could get a base printer with 1 tool head and then build up the others as you have the need and the finances to do it. Very awesome build. This is a water-cooled X gantry and idle bar tool head system. So a little more complex than a standard printer, but definitely it's an awesome printer. We did get first movements on it when we started this stream. If you want to look for the VOD, I will have the VOD on Twitch as well as propagated over to YouTube because it stays there a little longer. We did start this stream off doing a homing sequence just to show everybody that we do have movement on it before we took it down off the bench and started working on the Prusa MMU. Hey, Darth Gollum, welcome in. 25 days until Murph. Yes, thank you, Pez Liz. You're going to get my anxiety going, but it's all good. I need to get countdowns on my Windows and my Mac so that I have those. By the way, on this stream, we do drink coffee. So I've got my Dunkin' that Mrs. Dragon got me earlier. And then if I make coffee here at the house, it's Black Rifle Coffee Company, which is a veteran-owned company. We will be changing over. And normally, on a more planned stream, I will have a coffee mug. Maybe mine, it may be Pez Liz's or maybe 3D, S Rona 98, who's a cosplayer and 3D printer, or, you know, various people. I know I have a couple of 3D print SOS. I'm not sure if I got a MakerMind Nexus. Can't remember, but anyhow. You have a P1S with AMS, so the tool changing printers are attractive for their differences rather than ones with exactly. So here's what we've been working on this channel. So we've got a Bamboo Lab AMS, and I can tell you, I love this system. You can't knock it for a out of the box point and click. It is the closest thing to, I'll say, a microwave or a 2D printer that we have, right? As far as a multicolor, multi-material system. Beautiful. Right now, I don't know why it's not showing up on screen, but actually I do know why, because I don't have it on this. But I do have a live feed coming from the camera of that, and it is printing parts right now, yes, through the AMS, out of Fadis ASA glass-filled um, filament. I'm also printing the black parts for that out in ABS carbon filled. So yeah, I am probably tearing some things up in the AMS, I know, but here's some of those parts. Whoops. These are some modified parts from C-Builds, but that's the bottom surface. I am printing on the engineering plate. And once again, this is glass-filled Fadis ASA. Really no tuning. The top surface finish could be a little bit better. I think I may be over extruding just a tiny bit. But all in all, these parts are coming out beautiful. Once again, this is a Fadis ASA glass-filled blue. And then I've also got my black. This is ABS carbon fiber. Once again, the top feels like it might be just a tiny bit over extruded, but it could be the carbon fiber. But the prints are coming out gorgeous. I didn't notice this had the Millennium Mills logo in it, otherwise I would have did it multi. But the primary multicolor that I'm doing with it is going to be the spindle housing cover. But so far, yeah, I know I'm probably going to be chewing up the PTFE tubes by running the glass and carbon filled through it. That's fine. One, my kit came with a second set of tubes. Two, I fully plan on getting a Capricorn kit to replace it. But yeah, all of these parts are coming out really nice. Like I said, I could have done the Millennium Mills logo in black on there, but I think just doing the one accent piece is perfectly fine. These parts are coming out very nicely. So yeah, I'm very happy with the prints I'm getting. I've also been doing my maker chips in PLA, and those are coming out. I've got like, I don't know, a few hundred of those already made for the show. So yeah, cap tubes, definitely, I'm going to be doing that. So, in fact, we were talking about the tool changer. Interested in getting a black box tool changer, go visit the Black Box CE configurator. You may not be able to order. It depends. So KB3D Chris is currently on vacation. So pre-orders are still enabled, but ordering from regular stock is disabled until he's back on June 2nd. He just didn't want people to order things and then not be shipped for a week while he's on vacation down in Florida. So the standard order system has been, I guess, disabled for the moment. But yeah, so we've been working on our MMU3. This is going to go on the Prusa Mark IV. And we've been doing a full set this year on the channel of multi-material and tool heads, or tool changers. So we have an Enraged Rabbit Carrot Feeder version 2 that is downstairs on the Trident 350. It still needs to be tuned. I've got people clamoring right now to get the tuning video up and done for people because they're at that stage and they've been following that build for a while. So I need to get to work on that. The MMU3 is going to be another multi-material alternative that's going to go on the Mark IV. I also have a trad rack that was built under a beta. This once again was built under a closed beta. So in this case, this is a 13-lane MMU, and the way that the trad rack works is it's very similar to the Prusa MMU. You've got a drive gear, or I'm sorry, not a drive gear. On the back of each lane, it's a printed part, a 623 bearing with a 10 millimeter screw, or excuse me, a M3 by 8 millimeter screw, I think, that holds it into the printed part, an ECAS fitting, and an M5 screw that holds it to the extrusion. Your only gear, your tooth gear, is in your Sherpa gearing that's on your tool head. You'll have a servo that raises or lowers your drive unit and the belted selector. So it's a little more simpler of a setup. You can get a lot more lanes out of it. But I'm going to be rebuilding this. This is based on closed beta. They now have Rev 1 parts out. So I'm going to reprint all the parts and the correct color scheme for the Annex Engineering K3. We will completely rebuild this. So we'll tear it all down, completely rebuild it, and with the latest set of parts, and it will go over on the Annex K3. I may not have as many lane options though. We'll see. But this is going to get built and go on the Annex Engineering K3. So we'll have a Enraged Rabbit Carrot Feeder version 2, the Trad Rack, the Prusa style MMU. We'll have a Bamboo Labs AMS, and we'll have an actual tool changer. So that's why I said this year on channel, we're going to have, this is a year of multi-material basically. So yeah. Correct. And that's the thing. So when E3D dropped support for their tool changer, which was it the Jubilee system? It's still out there. You can still build it, but it's very much you're going to be self-sourcing it. The nice thing with the XL is, once again, it's a single company. It's going to be a little bit more expensive probably, but it's the support you get with it, right? And that's the nice thing. The MMU, even the 2S, which I have on one of my Mark IIIS Pluses over at Evil Diesel's house. Yes, you've got to tune these, but once you get them tuned, they work really reliably. And if you have issues, single source of parts. You go get parts from them. You can get I say single source, you get parts from Printed Solid, who is a Prusa distributor in the US, right? So you've got things. So okay, Bexy Beans, go get some rest. We'll stay in touch. We'll chat throughout the week, I'm sure. And yeah, I know he's probably listening, but we need to do some conspiring between me, you, and Phantom, even more than we've already had on against Maker. So did I say that out loud? Yeah, okay. So fix the cables. Let me see. Okay, it wants us to do some more cable management around the back. So on this lid, there's, see these little slits? That's places where we can run zip ties down through. and zip tie our wires up even more, I'm assuming, to keep them up and out of the way. Um, I mean, these are pretty. I guess we can get a couple zip ties up there. They're not going to be completely out of the way, but they will be somewhat up and out of the way. So we'll get a couple more zip ties in here. Just trying to keep them up out of the way because your filament's going to be coming in down. So, okay, bye, Bexy. I will. Yeah, you love conspiracy? Yep. Okay, I will DM you. For the price of the XL, it should be tuned and working out of the box. Yeah, I understand that, Stephen Poole. That's one of the things that I will say is that's some of the things that people have issues with is that the tuning and stuff should be a little bit more robust by this point. Um, whoop, whoop, this one, trying to make sure that I get these down and around everything that should be around. This is where I'm going to get caught because I'm trying to use my own without opening up the ones I got from them in the kit, and mine just aren't as long. These are going to be crazy long. These still fit, or are these too wide? I guess the issue is I'm just trying to be lazy and not open up another thing of zip ties. I've got zip ties all over the darn place. So if I could use ones I have already opened up and not have to open up a bunch, that makes me happy. So at some point, I'm going to need to go and get all of my zip ties organized. Like my screws and all that. So what I'm trying to do is just get these looped around here. I'm not going to fully do them up just yet. I just got all the wires at each point. Okay, that. Two set and third one. This one's just going to be the power distribution and the motor cable here. And I'm going to pull this one like loop cable, but that motor cable will get looped into this zip tie. You find it's going to come out of the motor or the thing, come up. Shows it as being pulled over, so I don't know. Maybe we'll we'll fully loop this in. Fully loop, I mean. I'm going to take this, pull it over, pull one edge tight, kind of get it in there like that. And once again, because here's our inlet for all of our filament, that's going to keep everything up out of the way, keep everything from catching in with ears or anything like that. So makes the wiring a little neater. Trim off the excess tails. And I think pretty much done with this unit. Leave as much slack as possible in the cable bundle between the motors and the electronics so the unit can be opened up later. So we've got some slack maybe there. So let's actually try it out. Let's open it up. By opening it up, we're just going to undo some screws here. And the nice thing, so one of the issues we had was the screws would fall out of here on the old MMU2. With these coming over, it kind of keeps those screws from falling out. Get these fully undone. Okay, so at that point we are catching. That's much as we can pull over. That's going to be about as far as we can go opening this up. But then again, I think that's still pretty good. You're not going to be doing a lot in here. If you're doing anything, you're messing with filament path right here. So just having that much to open up actually works out well. There's no need to really flip it over all the way back because once again, your filament's coming in here. You don't want to like bend over and crunch your filament either. So I think we're good. Go ahead and get this back down. Equal pressure. Now we're going to start working on the frame parts. We've only got a handful of parts left. Shoot that forward. We're going to need 6 M3 by 10. Yeah, my Mark IV was actually I didn't get the kit. It was a full build because I wanted it sooner rather than later. But yeah, it's a beautiful piece of machinery is what it is. It has just worked. I haven't had to really tune much of anything on it. Um, once you get your initial layer down, it's just printed. Every time I throw something at it, biggest thing is which plate do I need on it, the satin or the plain PEI. I use it to print all my TPU stuff for printer builds or anything else. So it's worked really, really well. So we're going to take our MMU And we're going to flip it over in this orientation based on their thing. So one motor, I'm going to say facing me. We need to take our two square nuts and put them in the slots to line up with these holes here. There. And one here. Square nut that has like thick edge. Pull a little bit. Oh yeah, like I said, I've got a ton of zip ties. I just need to kind of figure them out of which ones are which size and organize them. So for the feel of it, that is something in the plot itself. Let me, yep. Bit of an overhang. Good, hopefully. There we go. Push these all the way in to make sure that they line up. Go. We're going to add the frame holders. Once again, this side has the, I'll say the front facing edge. And our frame holders go like this with this edge facing me. And we're going to use our M3 by 3 by 10. Screw this down. You have zip ties for your, well, that's what I did here was I just took a zip tie and zipped it together. But yeah, I've got zip ties all over the place. I just need to organize them. Fix frame to the holders. Over here. Probably sounds a bit stupid. Why did my FDM Ender 3 V2 struggle printing models supported with resins? Doing good, Nova Ninja. So if you're trying to print out a pre-supported model that was designed for resin, the number and amount of supports that resin uses, one is just kind of crazy, and then two, the they're small and fragile, which means that you're they're not printed in the same way that an FDM is. Because of the 3D printing methodology. So yeah, you would have killed an Ender 3 with retractions trying to do that. Yeah, resin supports would not work very well on F. Okay, so we've got our M3 by 10 screws put in to hold our brackets on. Next up, we're going to flip it over as if it's going to sit there. It does. This, and we're going to have a spot for our MMU plate to fit on here. That plate's going to go right there, and we're going to fix it with two M3x10s, and we never put anything in here, so this is going to go be direct threaded. And quite honestly, you can do this with like an M3x6 or an M3x8. I know there's a bunch of M3/6s in the kit, but we haven't used a bunch of them yet, so 10s are way overkill for this just being a cover plate like. So this could definitely be done with an M3x6 screw instead of a 10. This is just giving you a pretty plate. And I am sure on the printed parts that this would be an optional part that you can wait and get your MMU built and then print this part out on the MMU. So quite honestly, I think this might be a vinyl sticker on. You could definitely print this out on the MMU itself, which would be a cool first print. But there you go. Got that done. Now we have the rear PTFE parts preparation. Following step, please prepare PTFE tube 4 by 2.5, so it's 4mm outside diameter, 2.5 internal diameter by 650. 5. Okay. So those I know are all the way down at the bottom of this box. So here are those. We'll need 1, 2, 3, 4, 5. Oh, excuse me. Got 5 of those. Oh, hey, look, there's even more zip ties in here. Awesome. Oh, sorry, folks. Okay. 5 PTFE tube. Rear PTFE and slit. Insert the 5 long PTFE tube openings on the back collets on the back of the MMU. So we're going to come around here on the back side. We're going to have to stand this up a bit. This. Okay. Oh, okay. We have our 5 collets here. This is where we're going to stick our tubes. So undo the 2 idler tension. First off, insert the 5 long PTFE tube openings, back collets. Now on, if you do the PTFE, push the black collet in, pull the PTFE tube. Okay, so push these in. You're going to make sure that you push them all the way in. All 5 are pushed in. Undo the 2 idler tension screws. Open the unit. Don't worry, the screws fall out. There are small windows next to each of the pulley positions. Verify the PTFE fully inserted and its end is visible inside. Not push the tube in. So it wants us to open these up. Be looking for these little windows, just like we were looking at the little windows when we were putting in the 19mm pieces. So going to turn this around and set it up. this so that the tubes are off the bottom of the shelf and out of the way. I'll take these 2 screws loose. Oh yeah, yeah, allergy season is sucking. So these 2 bolts that I just took off, they hold the plate on, but there's springs there. So as the give me a second here. Still stuck on. As the um, pulley motor will rotate, well, not the pulley, the selector motor, the idler motor, it turns these gears. And as it turns, you'll see that this top portion will spring load up a little bit. That tells you that the bearing has rotated over the top of the drive gear and has pushed that. This is your tensioner, right? So a standard, think like an Ender 3 where you have to use the tensioner knob to apply tension, because on an Ender 3 you've got a drive wheel and a bearing. That's exactly what this is, a drive wheel or drive gear and a bearing, and you're squishing the filament between the two. The one surface has the tooth gear that's pulling the filament along. The other side is a idler bearing that's just able to roll. That spring's putting the tension on the filament between the two surfaces, and if you're slipping, then you can apply a little bit more tension, which will move that bearing down and give you more tension and bite with the teeth. If you're grinding, you want to loosen it up some. And yes, you guys are hearing the allergy stuff. So once again, we've got little slit windows here. So funny. Look for clear tubing between slits in a black part. Really not easy to see. But like I said, I pushed these as far as they would go. So I'm going to assume that they are in there good and proper. You know what happens when you assume, but I'll go out on a limb with my assumption. So I think we're good. Like I said, you're looking at this spot right here and trying to see the yeah, and trying to see the tube. It's kind of a hard sight to see. I'll put it that way. My assumption is we're good, that I shoved this in there as far as I could. I guess one thing that I can do is I'm going to take a Sharpie. I'm going to mark one of the tubes right at the collet. Push the collet in, pull the tube out. That's how far I'm going in. See the mark there? That's a good amount, and based on the visibility here, that is most likely going all the way through. Because like I said, That's as far in as it's going to go. So we should be good. Close the unit, tighten the idler tension screws slightly. Adjust both of the tension screws so that the top of the screw head is slightly above the top surface of the idler body. Let me see if I can get it. So you can see the screw head right there. So if you can see how you can just barely see both screw heads. That's what you're trying to do, is get that even tension on the two sides. This is the setting which works for the majority of materials. Some specific filaments might require a slightly different idler setting tension setting. Correct idler tension is crucial and might require further adjustment on your MMU unit. With too low idler tension, the MMU unit can struggle with grabbing the filament properly. With too high idler tension, the idler will struggle with determining its home position and the MMU unit won't work properly. Okay. Stickers and parts preparation. Following steps, please prepare the serial number sticker and the safety sticker. Ooh. Move the safety sticker, protective layer, apply the safety sticker onto the right side of the image. That goes above our two motors. So it's going to go like right here, which is going to be fun with all of these cables. So we'll have warning sticker. I feel like this might have been something better suited to put on earlier. So one sticker applied. Apply the serial. Same mechanism ensures it clearly and properly. Want this one on the other side? Like, could we have not have done this, like, I don't know, before we had everything flopping around here, guys? Our label up here, things back here, and they want it to be reading from this side. So could have been a better way of telling us to do. I did a little bit lower than they were suggesting, but it's on there. We've got an ad. I'm going to take the next few seconds to blow my nose real fast. Okay, so about 20 seconds left of the ad. And let's see where we are. This one comment right here of you're probably better off putting the stickers on. Yeah, order of operation wise, I think the stickers would have been better to put different, at a different time. Okay, so here's the thing, folks. I was planning on being done at, switch my camera view. I was planning on being done with this stream at 5. Just realized that it's about 6. So I've gone an hour over what I promised Mrs. Dragon. We've got the main MMU put together. So I'm going to say yay, hooray us. We've got our main part of our MMU. The next part that is up in the manual is the cassette buffer assembly. That's probably going to take a little bit. There's 20 steps in that. Let me see. We've got the cassette buffer assembly, and then spool holder assembly, bonding the next extruder, which would require us to actually get the printer up and on the table. So I think what we're going to do is call the stream here with the base MMU3 built. And then we'll come back and we'll do another stream where we will go through the process of installing or building the buffer system and doing the spool holder assemblies, and then taking the time to bring the printer up here and do the necessary things to the printer tool head. And that way it'll also give me a chance to figure out what changes I need to make to my printer to get it to work. Because I know on the Mark III, you had to, I'll say, do like this little top piece and add it. Here it's going to be a little bit different. See what these printed parts are for. Okay, so these are the actual printed parts for making the mods to the Mark IV. So that'll be good to know. I'm going to try and put all of the spare parts in one bag and then package up all of the screws and such in another bag. Just kind of clean up. Normally tomorrow night would be the actual sorry, apparently my brain's not functioning and I can't multitask. Tomorrow night would normally be the BZBot build. We may just continue with this. That way I can leave things kind of out and on the bench. Somewhat just cleaned up so I'm not like weirded out tomorrow as I'm working up here. But yeah, that way we can kind of keep some things out. And we'll continue this tomorrow. Yeah. We'll keep all of our tools that we've been using out here, but oh yeah, oh yeah. But here's our MMU3 basic build done. And like I said, we'll do the cassettes, we'll do the buffer cassettes, we'll do the spool holders tomorrow. And then if we have time tomorrow, we'll go ahead and make the changes to the Mark IV. If not, then we'll go ahead and make those changes Thursday or another. But thank you all for being here. I do need to continue on the VZ-Bot, so we might get one more stream on this before we change tact and go back to the VZ-Bot, because I need that one done for the show that's coming up in 20 days. So I don't want to put that off too long. But yeah, thank you everybody for being here this evening. Let's go find a place to raid out. It's going to be weird trying to find some place to raid out on a Monday. Not used to streaming on Mondays. But we might get to see some people that we normally don't see. Cool, Old Man Sim, Pick Stitch, Prophet DNA. We haven't been over to Prophet. Several people are doing games. Let me check out Prophet DNA real fast. So we got Mr. and Miss Prophet out there. Yeah, give me 1 second. Yeah, overall this came together pretty quickly. We did deviate and just deviate from the standpoint of conversation here and there. But yes, thank you everybody for being here. I'm going to set the raid up to Prophet DNA. Like I said, it looks like they're doing some brick building. But I will get us started over there. Get the raid started. So please join me and head over to Prophet DNA. Yeah, $5,100 Canadian is not that attractive, but something like Black Box, I think is probably going to be about the same. It's not going to be that much. Well, I take that back. I want to say Black Box is around 2.5 to 3.5 US, depending on what type of tool heads you want to build. But yeah, thanks a lot, everybody, for being here. Thanks, Pezlas, for the continuous countdown. And please go with me as we raid over to Prophet DNA. And I will see you guys tomorrow for another build stream. Thanks all. Bye-bye.